So here we have an example problem. We want to find the component form and length, which is the magnitude, of the vector v that has initial point 3, -8 and terminal point -2, 6. All right, so the first thing that we should do here is draw this vector. We should draw out our coordinate plane, plot the initial and terminal point, and see what our vector looks like. So let's do that. I'm going to draw the y-axis, and then I'll draw the x-axis. And let's label them. This is our x-axis, and this is our y-axis. And I'm going to say that this is x equals 2, x equals 4, and x equals 6. And then this is y equals 2, y equals 4, y equals 6. And then we have x equals -2, x equals -4, x equals -6. And then y equals -2, y equals -4, and y equals -6. All right, so now let's plot the initial point and terminal point. I'm going to plot the initial point with this color and then plot the terminal point with this color. So 3, -8 takes us to 1, 2, 3, and then we need to go down to -8. So let me extend the y-axis here. We need to go a little bit lower, and so we'll say that this right here is -8, and so 3, -8 will be right here. And so that's our initial point. I'm actually going to label that with A, and so I'm just going to put A right there. And then B will be our terminal point, so I'll label this with B, and that is at -2, 6. So if we go to our coordinate plane, -2, 6 is right here. So that is our terminal point, B. Okay, so now what we should do is connect these 2 points. We should start at our initial point and connect it to the terminal point to create our vector. So I'm going to do that like this. That is our vector that I'm going to label with V. So that's our vector v, and now what we want to do is find the component form of that vector. We want to put that vector in the standard position where the terminal point is at the origin so that it is a position vector. All right, and so in order to do that, to find the component form of vector v, what we need to do is take the difference of the x values and then take the difference of the y values. And remember, you use the x and y values for the terminal point first, and then you use the values for the initial point. All right, so for the x values, we have -2 minus 3, right? -2 minus 3. And then for the y values, we have 6 minus -8. So 6 minus -8. Okay, so now if we simplify, we'll have the component form of vector v. Now, -2 minus 3 is -5, and 6 minus -8, that's the same as 6 plus 8. Those negatives cancel out, and 6 plus 8 is 14. So the component form of vector v will be -5, 14. Okay, so that's the solution to part of our problem. We found the component form of vector v. Now what we want to do is find the length, or the magnitude. And that's going to be pretty easy now that we know the component form of vector v. The magnitude of vector v will be equal to the square root of the sum of the components squared. So we'll have -5 squared plus 14 squared. Now, -5 squared is 25, so this is equal to the square root of 25 plus 14 squared, which is 196, and 25 plus 196 is 221, and so this is equal to the square root of 221, which I believe does not simplify any further. And so the square root of 221 is the length or the magnitude of vector v. Okay, so now we have completely solved this example. And just note that if you wanted to, you could also graph this position vector. Vector v is the position vector of the point -5, 14. So if we extended this coordinate system, we could go to -1, -2, -3, -4, -5, and then up 14 in the positive y direction. And then we would have our position vector that starts at the origin and ends at that terminal point of -5, 14. Okay, so if you wanted to do that, if you wanted to graph that position vector, you could, but we didn't really need to for this example. We just wanted to find the component form and the magnitude or the length of that vector.